Assalamualaikum. Today we're going to talk about my proposal that is theory of car safety enhancement in Malaysia. Let me introduce myself. My name is Muhammad Nur Akmal bin Buhari and I'm from UTM, that is University Technology Malaysia, and I'm from course Bachelor of Science Mathematics. The most common type of accident in Malaysia is a collision between two cars, a car and a motor vehicle, or a lorry and a car. Because of the huge number of vehicles on the road, car accidents may be more common. There are numerous reasons that might cause accidents, including driver negligence, which accounts for 55% and 32% of all incidents respectively. Other factors in the roads that include lenient penalties for those who do not follow the laws and lack safety regulations. According to study, drivers in the United Kingdom have more polite and disciplined attitude than drivers in other countries. From such remarks, it may be deduced that road safety is higher and there are fewer accidents. Road accidents have several negative consequences, including lost wages, increased hospitality, property damage, and the potential loss of family members. Because the number of accidents occurring in Malaysia is increasing, this incident must be addressed correctly. In 1999, 223,116 people were involved in traffic accidents, with about 6,000 of them dying. From these words, we may deduce that everyone should be concerned about road safety and their attitude, which both need to be improved. In Malaysia, the number of traffic accidents has risen. In 1966, there were 248 road accident case records for every 10,000 automobiles that had a license. In 1995, this number had risen slightly to 268 road accidents per 10,000 vehicles. There has been a lot of work put into reducing road accidents, including physical road repairs, vigorous driving laws, and safety first campaign. Unfortunately, no amount of effort was successful in reducing traffic accidents. Drivers are responsible for 38.6% of these violations, 50.2% are negligence, 7.9% turn on the highway dangerously, 4.7% violate the speed limit, 4.6% cut other vehicle dangerously, 3.1% drive dangerously, 2.6% follow too nearly, and 0.55% are not obeying street lights. A new method can explain the difference between two collisions based on all these problem statements. The two colliding objects. Least square collision reconstruction is the acronym of the method. Let's call. It calculates the initial velocity components for the following: final velocity components, vehicle physical data, damage geometry, collision geometry, and impact coefficients, that is restitution and friction. Let's go determine any combination of 6 or less unknown beginning velocity components and impact coefficient using a 6-equation impact model and the least squares approach. Accident collision between moving things and other moving objects and vehicles are seldom without controversy. An accident reconstruction is performed when the circumstances call for a formal investigation. This study is concerned with the dynamics of a reconstruction, specifically the determination of velocity change that occur through the time span when the vehicles are in touch. If many impacts occur, the procedure can be performed repeatedly to investigate each one in turn. If the vehicles are articulate, a new impact model must be employed. Each vehicle in a collision has 3 velocity components: normal, tangential, and rotational. There are several ways for calculating the start and ultimate velocity of two vehicles colliding in a plane. It is assumed that a reconstruction of the vehicle dynamics after impact witness testimony and scenario evaluation will be performed. The approach to be given used the well-known least square method to identify a combination of uncertain beginning velocities and impact coefficient that satisfy the 6 impact equations and nearly match the required final velocity components. The approach under development will be referred to as let's go through this work. Vehicle collisions are extremely non-linear transition dynamic process. Material non-linearity is affected by several elements, including deformation rate, temperature, pressure, humidity, material age, and deformation history. Although the use of models helps to reduce of automotive design on physical crash test data for determining parameters and injury values to occupants, it did not fully replace real-time tests due to uncertain unavoidable assumptions that limit detailed analysis of the event kinematics. Every genuine collision results in a loss of kinetic energy. Vehicle crashes are no exception, with normal numbers ranging between 25% and 98%. Impact models use coefficient or velocity limitation to indicate energy loss. The coefficient or restitution is a traditional coefficient used in introductory dynamic textbook to simulate energy loss owing to material deformation in a normal or perpendicular mode to the crash surface. The ratio of the impulse components that form between the vehicle tangential and normal impulses is known as the equivalent friction coefficient. Although friction is frequently used to describe the tangential per impulse, shear deformation is likely just as important. Fortunately, regardless of the source or makeup of the tangential force, the model yields accurate answer of the right value of. For the proposed method, there is the data category for LESCO. So there is 5 data for 3 initial velocity components for each vehicle. At least 2 of the 6 must be unknown to be determined. Known values are simply specified. 3 final velocity components for each vehicle. All 6 known estimate from prior information. Impact coefficient may be known or unknown. Vehicle physical properties, that is weight, inertia, and dimensions, all quantities known. For lastly is configuration of vehicles during contact, that is relative angle and damage contact surface, all quantities known. For the formulation of the least square problems, a group of 6 or fewer of these 9 quantities are chosen as the unknowns. The conservation of momentum and friction loss may or may not be satisfied by this set of facts taken as a whole. However, for the given set of n velocities, there is a set of beginning velocities and impact velocities that match to an accurate solution of the impact equations. For these beginning velocities, it is frequently possible to just solve the impact equations backward. The 6 final velocity components that fulfill the impact equation is based on equation 3.1. So for equation 3.1, the 6 final velocity components that will fulfill the impact equation are represented by Vi and Vit. Is one of the Ni estimates of Vi. Many estimates are allowed, but normally Ni is equal to 1. There is a weighting factor that is Wi. LESCO strategy is to determine the unknown beginning velocity components, unknown impact coefficients, and a set of n velocities that minimize Q and satisfy all of Newton's law, notably the 6 impact equations. The usage of digital computer is required due to the intricacy of the problem. For the supply and velocities and all other data, the impact equations are utilized to solve for a beginning set of initial velocities. For solving least square issue, there is a well-known iterative approach that based on this equation 3.2. Reduced order dynamic models are another technique that may be used in conjunction with other studies. The techniques make use of finite element models with cost-measures lump parameters model and fine-grained lump models. One of the main issues is that these models' accuracy is impacted by their simplifications and lower degree of freedom, that is TOF. Additionally, occupants' motions and potential injuries in the calculation are predicted using lump parameter models. A reduced order model's goal is to represent the rigid parts as mass attached by springs and to calculate the force acting on the masses because of external impact and spring forces. The dynamics of a system are defined by energy rather than forces in the Lagrange method, that is equation 3.3, where in the general case L equal to T minus V and Qi, I must be equal to 1 until n are generalized coordinates. V is the systems of the potential energy and T is the overall kinetic energy of the system, which is equal to the sum of the kinetic energies of the particles. The term risk is used to describe a succession of stage collisions. These collisions entire starting and ultimate velocity and have all been measured. The values discovered by LESCO will then be contrasted with the values from previous experiments. An additional example is represented using a side-swipe type collision encountered in practice. This is the table 2 for the data for 2 example risk-set collisions. This is the figure 1, that is flowchart for LESCO computer program, and the figure 2 is coordinate and dimensions impact model. For the result, we got the data for the LESCO result for risk-set. And for the additional result, we use the trial and error reconstruction side swipe collision, and also LESCO result for a side swipe collision. For the research outcomes of the conclusion is, after experimenting the steepest descent approach, cost iteration procedure was selected. Using most of the input data and an inverse solution of the impact equations, an algorithm was created. The initial inverse solution procedure selects the coefficient that provide an acceptable inversion, since final velocities must all be given. The least square collision reconstruction technique is a crucial tool for accident reconstruction. The least square reconstruction yields far less subjective result than trial and error techniques, while no-on judgment is eliminated. The least square approaches are also significantly faster than trial and error techniques. For the contributes to knowledge, the components of road safety may be achieved by driving abilities and competencies, action while driving and after driving, and raising knowledge of risk and safety. The most crucial feature is that all the aspects work together to raise awareness and help all drivers become more cautious drivers. Driving institutes and schools should periodically update and develop the quality of their teaching and teaching materials to guarantee that they are effective, particularly in creating sensible drivers. For future works, I hope that the surge in fatal accident on Malaysia roadways necessitates immediate action by all stakeholders. Greed on the road is claimed top the leading cause of road accident, and if not addressed properly, more personnel will be lost, resulting in a loss to the country. The formulation and improvement of the driving syllabus on a regular basis is necessary to further improve the quality of driving training, so that trainees always receive the best training and can raise awareness of road safety, which can ultimately reduce the number of accidents, particularly fatal accidents in Malaysia. This is the reference that I use for study my proposal.